go live button so that we can record that.
Perfect. So, one second. You want me to share my screen and start, or?
Yeah, I can make an introduction. So,
yeah,
everyone, welcome to today. Our I guess our final session on knitting presentations from architects around the world. So we have today with us Nikoletta, I don't know how to pronounce your last name, Nikoletta Karastathi.
Yeah.
She's from the Bartlett, where she's getting her PhD and studying. She's just entering her second year, so she's pretty early on. And so it's quite interesting to see people at different phases of their research, but she's been working with knitting and bio design for quite some time. So please welcome Nikoletta.
Hi guys, nice. Thank you very much for the invite. I'm very, very excited to be with you here. Yeah, so I'll share my screen. Give me 1 second. I'm sorry. I was getting the wrong screen then. Like I haven't done it so many days. I will get there. And share screen. Yeah. There we are. Okay. So, I mean, the presentation has a few different projects. Some of them are more fabric projects, some others are more knitting projects. But you will see that the work is primarily, or in a lot of parts of it currently, is quite speculative. So it's not very, and it's small scale as well. It's not like big architectural scale, but it could potentially be thought provocative and give you different perspectives of how it can be used. The first slide is, is one of the reasons. So when I started initially looking at textiles, I was just very fascinated with the amount of things that you can do with textiles and in how many sectors you can find it, and how little in the end we currently, or hopefully we do a lot more of it in architecture from now on. But you have like advancements in medicine, fashion, and also like in very extreme environments. So imagine you're in space and you're wearing a spacesuit, like, and all of it is made out of fabric, and how the programmability of the fibers and the technology, how far can it be pushed. So I think these are some of the reasons that I'm very excited with the textiles. And now I will jump to how it all started. So this is actually a project, maybe it's even like 10 years now. At that point, I didn't know that I would be working that much with textiles, and it was an exhibition done in Greece with a colleague of mine called Haris Heizanoglu, and we were looking at soft spaces and how the body relates with the space, and how you always, how would it be if you were to knit your own space? What relationship would that make with the space itself? And also it was about the computational aspect of it. So how can you translate something like a knot to something textile within a digital context? And that kind of evolved throughout the years. And I started working with textiles, I think it's about 5 years ago, in a master's I did in Newcastle. That it was about computation, and I was very much interested into knitting. So my work currently sits at the intersection of textiles, architecture, computation, and material science. Different parts from each field. And I'm sure a lot of this you might have already seen, but why knitting? Because it's a rule-based code, it forms continuous lengths, and it has zero waste for fabrication. Each stitch is connected to the neighbor, so it can be pliable as well. And you can adjust and readjust the structure, as you're doing nicely with your pavilion as well, that you would be making. And the material performance also is related directly to the fabric itself. And for me, what was important once I started was to understand the layers, to understand the process of it, understand it from a fiber level to what is the impact that the pattern has, and also what is the impact. So once it's exposed to moisture, for instance, or other environmental factors, how can it self-adjust on that environment? And some of them are quite old slides, but I thought it would be nice to see the thought process I went through. And then I started looking at different types of fibers, or understanding what is a protein, a natural fiber, what is man-made, what is the impact, how do they react with the environment, or with moisture, or with UV light. And these were, again, very, very early examples of just working with wool and cotton and understanding the tension and the patterns of textiles, and also looking at understanding on that kind of fiber level, why, for instance, the wool, when it's felted, you have the fibers that they get entangled with each other, whereas cotton, it has a different fiber structure, that's why it remains as it is. So I was quite excited with that part of the understanding from a bottom-up approach, the design process. And again, here, very initial examples at that point of understanding all the parameters. Again, you would have gone through the different needle beds, or the yarn types, the tension, the gauge, the knitting types, the patterns, by doing different prototypes. And when I started off, it was just at the beginning to understand the different techniques. I was interested in tarsier loom knitting, because I wanted to use specific materials in a specific part of the process and not carry the yarn from the back, which I assume you would have gone through that already as well. And a few very early experiments of how crazy you can go with hand knitted structures, which potentially, I know currently maybe you can't do it within a machine, but it was just a kind of a free-form exploration through knitting. And at some point, I said, I need to get a machine, because I didn't have access. I still don't have access to big knitting machines, but I got a brother, so I could start. I tried to start scaling up those pieces. And also in parallel, as part of the design process, was how do I want to activate my form? So this is something that potentially might have happened to some of you. So I was interested in how can I use this error or this method of shrinkage as part of activating the form that I want to use, or that I want to create. And other forms at that point I started looking, again, very early on at the beginning, was felting, as we said, or either crystallizing parts of the structure, UV resin in specific parts, or fabric thermosets. So the thermoset fabrics are made out of, I think, 2 different types of polymers, and once they're heated up, they shrink, and again they become quite, it depends on the thickness of the fabric, but they can become quite solid. So at that point, I started saying, okay, if we have those forms, how can we start using the shrinkage rate as a form activator of the final form? And going to the initial kind of simulation part of the process, because I was interested to simulate it in a way, but at that point I wasn't very much interested to have a very, very accurate simulation. So I was translating the knot of the knitting within Kangaroo as a particle system, and then I was able to control the shrinkage rate depending on the pattern that I had. So very easy early examples of just testing, depending on my sample sizes, how it would shrink and how it would react. And there's again, initially I was started looking at how do I want to generate my pattern. So I was very much interested in the minimal path system. So how can that be kind of the pattern activating design of, yeah, how can I make knitting patterns out of it, or based on the system. And here you can see some very early examples of how it shrinks or how it forms based on the different patterns. And following on that, I was lucky at that point. There was an exhibition there was a call for an exhibition at the Baltic Center of Contemporary Art, and they wanted a quite large piece. So it was a good opportunity for me to try and scale up and see how that works. So this was the whole exhibition setup, and each of us was given a kind of a triangle that we had to do our piece. So in my case, I followed exactly the same methodology. I kind of created the pattern within Grasshopper. Then, because it was quite a big piece, even if I had the machine, I couldn't knit it all in one go. And because of limited time as well, I ended up knitting the components separately because it was just quicker, which is not the most efficient. That is what I could have done at that point. This is the machine and the process of making the piece. And here were the different components. Again, it's made all named and numbered, made out of wool and cotton. Here you can see the scale of it before it's felted. So it was quite a large piece, and me being very tired after putting it all together. And once it's felted, this is kind of the output. So the cotton kind of bumps out and the wool shrinks. And on the back of it, I also have added, so in order to have the nice bumps, I also used as part of the process the thermoset fabric. So then it means that the bumps would remain on the shape that they have. In an ideal environment, in an ideal world, I would have wanted it to be together interwoven with the cotton, but it was quite thick to pass from the machine at that point. And this is a close-up. And a very similar piece again was done for the London Design Festival 2018. That again, the process is very, very similar. Again, we had we have a hexagon that we could fill in. And the pattern generation or the form generation was exactly the same. And it's primarily, at this part, it was primarily either aesthetically or just trying to understand how the form would evolve. There was not specific requirements. I also started, I think that prototype has also linen that also with moisture. I was interested to see how it reacts to the environment that it was at that point. And it just gave, and it was nice to see how the light comes through the pattern. And again, these are the same pieces, but lighted up from the back to see the effects that you can get. So these were how I kind of got into it in terms of understanding the knitting process, the patterns, and the understanding of and the properties of the materials. But then I started being very much interested in how can I make the material that I want. So how can I make the fiber or the fiber itself? I mean, clearly the fibers I make are not, you cannot pass them through a machine currently, but I started being interested in polymers or extruding the yarn and making the yarn. So this became my new tool set. So I was using, I'm using sodium alginate, which is what you can find at the cell wall of algae, chitosan, which is what you find on the shrimp cells, which is what makes the yarn. It depends on the consistency that you use it, and it can make the yarn a bit more stiff in a way. And calcium chloride is what cures the solution. So the process is that you mix them all together depending on what you want to achieve in different consistencies. Then you extrude, you put them on a syrinx, or you could even use a robotic arm depending on how you want to extrude it. And then you pour it into calcium chloride, and you have that yarn-like format. And I think the next one should be a very, quite quick stop motion of the whole process of making the yarn. So the yarn, once it's out, you will see a bit later on as well, it has high consistency of water, but within days, if it doesn't remain hydrated, then it kind of starts to shrink. So it shrinks, I mean, it depends again on the consistency, but it can shrink up to 1/3 or even more. So the initial part was to to start understanding the different consistencies or even the different extrusion rates from the different searings, and also coloring with either natural ingredients or not the yarn itself. And here you can see an example. So once it dries out, it kind of shrinks as a hydrogel. But then if you put it back into water, or if you hydrate it, if you see here, it starts expanding again. So in terms of principle, again, I find it quite similar in a way with what I was doing before, because it's all about that kind of actuation or that kind of movement. And this having become my tool sets, my new tool set, now I'll show you two they're very more arty projects. They're not very architectural that I did with them. So again, they're for London Design Festival. And this particular project has two different aspects. The overarching idea was that at that point, we were collaborating with a clinician, and we were looking at antimicrobial resistance. So we wanted to raise awareness about antimicrobial resistance, how different, maybe let me go on this slide. Yeah, so how different countries, depending on the antibiotics they give, they have a higher resistance, and how that can become quite dangerous. And using knitting and actually the barrier as a way to show how that happens in different countries, more like the data visualization method. And the yarns were also, I also used thermochromic pigment, which you'll see there that kind of changes color if it's heated up. So the idea behind that was that we wanted to say that I forgot that. The resistance rate is low in the areas that are quite light, the color, and as it goes darker, the resistance goes higher. So the idea was, with a thermochromic dye, what we wanted to show is that if you start controlling the way that you use antibiotics, then you can reduce the resistance, thus the change of the color. So it was used more as an effect to initiate conversation and make people understand the importance of the topic. And then there was this piece as well, that the idea was that we also wanted to create a speculative garment that is made out of, the consistency of it has also bee pollen powder and acai berry beans, that are supposed to supposed to help you fight a specific strain of bacteria, let's say. So the idea was that you create that garment and it kind of helps nourish your skin. So it was just looking at how can you program the fiber in relationship to the skin and how that can benefit. And also, again, it had the thermochromic dye, because we wanted to say that, speculating that if you were in an environment with high resistance, the garment would change color. So then you would know I'm on an environment that has high antimicrobial resistance, and then you're more aware of your surroundings. Highly speculative. And also on this piece, other thing that we were quite keen to explore is not only because you need to take care of the yarns. If you don't hydrate it, then it kind of shrinks and dies. So it was also the notion of how would it be if we start taking care of the garments we wear, not only the garments, but that could even extend to the living environment that we live in later on, if we were to again translate it in a different way. So yeah, this was the piece. And then the last one that I want to share with you is, again, another piece, again, the same principles used, but this time, instead of using the powders, I started using algae, so different consistencies of algae. So in the making of the yarn, we induced different, so some of them, as you can see on the right, you have more density, and some others have less algae. you knit, you extrude the yarn. It's the same process. And I've knitted a piece that was about, I think that was about that big. And also the idea is that you, again, if you wanted to stay alive in a way, you put it in water, and depending on the light conditions or the nutrients, you would see it within days. You would see the algae growing within the fabric. And this is a close-up that you can start seeing those. You can see that it started from a very kind of linear process, that you had something of high density, like quite green algae at the top, and then some parts, depending on how it is located, it starts dying in some parts, or it starts being more happy in other parts, and it starts having that more organic pattern. And further on this garment, it was also the idea of that within time that would start actually to be, and it did start decompose or deconstruct. So the notion of time comes in as well. So is it something that you make and then you throw away, or does it gradually degrade or go away? And here is how, when it's completely dry, that's how it looks. It looks like noodles in a way. But then if you pour water, I mean, again, algae clearly at that point is not alive, but you can see that it kind of swells up and it becomes again soft. I think I did run. And this actually, I took it a bit quick, didn't I? Was I running a lot? I tried to keep it on 20 minutes.
No, that's perfect. I mean, 20 minutes is good. We don't need to overwhelm everyone. I think that was really great. It's definitely really different, I think, than the other presenters we had this past week, because we had Mariana Popesco and Annika Klaas, who's coming from fashion design. So being able to see that biological side and how you can really play with the material itself is quite interesting. I mean, I definitely have a lot of questions. I don't know, because you're working with hand knitting now, because is it partially because this material is too delicate, or the size of it? So I mean, I have tried to knit a bit with a brother machine or with small loom knitting, and with a lot of care, and if I take it slow, you can do it, but they're quite fragile. And I found out that it's quite easier if you let them dry a bit, and because if the ones that are out, they're quite squishy and not flexible, difficult they can easily break. So I think, the challenge would be, really is to go ahead. I mean, clearly, I don't think I can do it on my own. It needs a material scientist to be able to help me, or you need to potentially weave something else and maybe weave it with it. But industrial machines at this point, I think I would just break the machine. Yeah, interesting. Do any of the students have questions?
Shall I stop sharing? I can stop sharing.
Yeah, you can stop sharing, unless they want to see some of those images again, but I think we're good. Yiga, do you have any questions?
Yeah, I have. It's quite inspiring. Yeah, it's quite inspiring for me. Like, you engage with the material scale. I've never dreamed of making my own yarn. Like, for me, it's because I usually work with industrial knitting machines. So what I doing is just choosing from the catalog, and there's already a bunch of different choices I'm struggling with and trying to figure out what are they, what I can achieve with them.
What do they do?
Yeah, you provide me another kind of, I can directly just go into my Go and make my own yarn. And I've also have a very naive idea once, and I drop it, but now maybe I can have a try that, the world is struggling with the plastic issues.
Mm-hmm.
So I've already seen some technology that we can turn plastic bag or those PET things into yarns again. So for me, it is not, it will be a quite interesting step if we can establish a chain, maybe to recycle those, like from the personal protective, the garment, and trying to make them into yarns. Maybe those yarns are not fitable for fashion or garment close to body, but they may be useful for like fabric formwork or other things, or geotextile. I don't know. It just gives me a lot of inspiration. And also, I would like to. I have a question, like, because I see a lot of fundamental research in your presentation, and so will you have an image or final imagination what are you are going to make during your research? Like, so you want to replace the fashion, the knitwear, or you want to use this kind of biomaterial into architecture? So do you have that always in your mind, or you just I'm just curious about the process. I think because we are very familiar with that, I have something to build, so and then I go this path. But I find that you have a quite different approach and have a lot of very interesting fundamental discoveries during research. So I'd like to hear how do you just how do you push your research into certain direction, and do you have a final imagination, like of your research?
I mean, I quite, it is, I quite struggle, to be honest, to see how, because I quite like, it's quite intuitive sometimes. I just get excited with something and I go in a specific direction. At the point in a more, if we take it on a more theoretical level, which is actually at the past few months, I was even reading Greek mythology and things about understanding more about the meaning of the pattern, or why do we weave, and in a more theoretical level, I'm interested in how those constructs, or how can this textile create more that dialogue with us and the environment. I know it's far-fetched, but this is this is how I saw the garments as well. So the garments were for me a way to think in a different way the relationship we have with the bacteria, or the relationship we have with the environment, and create that threshold. And I think especially textiles have a lot of that, because I can if I have a vision, I can imagine, and I know it might not happen, or at least within my PhD time, but I always think of a quite complex textile structure that hopefully could be even built or be interwoven, or even as a kind of a spacer textile, let's say, that you have part of it that might be living, or you can have another part that is more structural or is more tension active. So how could we really program, and it doesn't have to be all either biopolymer, so how can we kind of, what is the dialogue that we want to create with those materials, and within a building envelope, what would the envelope be? It's not very specific at the moment, and it's more kind of in a theoretical or in a bubbly world, which I find hard to sometimes justify or know which direction to take, because in a way, I know I could either go very specific on doing simulation, or very specific in looking at even making one yarn, but then I know that's not my expertise. I'm not a material scientist, and sometimes I find it hard to know where to get out of one field and come back to architecture, if that makes sense. So how can I bring this together? I don't know if I answered, so I don't have like a specific output, but ideally
破纸的时候就缺金黄的。
but yeah, ideally it's that is the exploration of the envelope based on the programmability of those knitted materials. I would say.
Thank you. I find
I have a question though on the because I've also been playing with like wool and cotton and shrinking yarn, and part of that is also like I'm also working on like simulation of these things and using AI to try to understand those transitions. But I'm also wondering how you tie that into the newer work with the yarn that you're creating. Does that have different shrinkability to it as well? Or is it in ways that like if it's wet in one part and dry in another, it's got different kind of formations that start to occur? And
I think
how do you program that, or like, I don't know.
It's quite hard to, well, or at least at this stage, because they're biopolymers, or at this stage they're not very well set. Even if so, I started and I have some other samples at home now that I try to actually test the specific shrinkage rates of the biopolymers and kind of simulate it and see how we can. Some parts maybe are more, they shrink more than, so the overarching principle remains the same, but it's more difficult to control the behavior, I would say. Like it's more difficult to say that this part would shrink that much, because then you never know exactly how it would behave, which is a challenge. But equally, if I don't know if I would be able at some point to say, okay, this is my tolerance, that I don't mind, like I can let it up to a point do what it wants to do, but I don't know what that point is, because equally we need to design and control something. So it's finding the balance of that. And in terms of simulation, I currently am not. I think I use it more of as a design, like as a way to think how would it come up, but I'm not very fixated, or is it exactly this? It's more of a form finding, maybe we can say, process. Yeah.
I also agree that I try to simulate the behavior of knitted fabric, even though it's
even it's a set. Yeah,
but it's quite difficult to accurately assume that, and I also find it pointless. Like the goal for us is to give inspirations for design. It's not to simulate it so accurately. So but if there's accurate way, of course it's better, but if it's not, I think it doesn't matter that much. Yeah, I agree with that point.
Yeah, I think it depends how you or what you want the fabric to be or to do, in a way. Like if it has to be fitted on a specific dimension, then, and there's a lot, I mean, you can either take I assume you wouldn't want to tailor it on the spot, but what I love about fabrics is the pliability that they have as well. I mean, the ones that I'm using are quite fragile, but clearly if you have like things that stretch, is that kind of interaction they have with the body and the space. I think it's amazing. And the fact that you can have some set parameters and then potentially you can adjust or work with what you have.
Hello, I have a question. Okay, I'm sorry, I'm outside because about cooling today I'm waste. And I sent a link in the chatting bar, and because I found this very interesting structure, and it's made by glass, and it's in between the material research and industry research. Because I found this artist since she first making a model, and later with a wax, and later putting glass inside, so it's keeping the shape of knitting structure, and also very translucent and colorful, just like the work inspired me. And I don't know, it's not the same pattern like you develop with the material first.
I think I missed the question in the end. So the question was if it's a similar process, or
why it's the similar question like Igor said. Why you start with the material first? You're not satisfied with the current material, or?
I think it was the prototypes with the biopolymers that were more experimental, because I was very much interested I was just curious, to be honest, to see how can I make it at home. I found it exciting that I can just make some yarn at home. It was not, I'm sure, I mean, there are plenty, or there is a company called Alginate, or there are plenty of companies that they are actually looking into making properly the fibers for knitting machines. So my process was more experimental and more thought provocative in a way. What is the relationship of the garment with the body? Can we have something that we take care of at home, or can we, I don't know, enhance the nutrients? Or, you know, sometimes you can have an eczema on your hand. So it was more of the, in a way, speculative and theoretical, other than me trying to say, okay, I want to make a new yarn, because clearly there are people a lot more capable of doing that than me. So I would say curiosity and the art exhibitions were a driver for that.
Okay, thank you so much.
I'm a curious person.
But I think that there's a lot of potential. Like, I mean, I think there's a lot of yarns out there that already exist. But then there's also things that we haven't invented yet, right? And there are ways that those might be used. I think when Mariana Popesco was presenting her work, because she's using the knitting as a formwork, right? And it's like, well, what do you do with that? Do you take the formwork down? Well, sometimes the concrete's kind of like stuck to it, but then the fabric is there and it maybe doesn't always, it's hard to clean. So like, are there opportunities for it to actually dissolve or biodegrade, or using different yarns that are self-cleaning and things like this?
Exactly.
These are ways that we need to develop on the fibers that already exist and create new materials. And then I think like with yours, there's this whole idea of changeability and deployability, which is, I mean, in our workshop, we're dealing with deployable structures, right? So the way that material could be activated by moisture, right? It could totally change the shape of a structure. Of course, right now it's very small, but the thought is like, once it gets bigger and better and the yarns get more developed, you know, there's these potentials that, you know, it rains and you're building just like
exactly, or it falls up, or it's yeah, exactly.
I mean, it's just like an amazing thought. Like we're not there yet, but that doesn't mean that that's not the future coming. So it could be very interesting.
Or you can have, exactly as you said, different parts of the building that dissolve, or different parts of the building that become solidified. I'm sure you might, or the students might have seen the work from Bastian, that he uses knitting and bacteria to kind of solidify a knitted structure. So again, that has its own difficulties in terms of, it's always the scale that you work, it has to be in a specific environment to grow the bacteria, but equally is exactly what you said. We can speculate that parts of it can degrade, other parts can solidify within time, and then really adapt to the environmental conditions of where you are, and not leave any, and even when they become and then they become nutrients for the ground. So again, quite I mean, it is speculative, but we've seen that with the mushrooms, with the bricks happening. So it's not, we're not material scientists, but we can really see how potentially that can really push some things on the built environment, or even on the facades, or
so many options. Well, thank you so much.
Definitely. Thank you for having me. It was a pleasure.
So thank you. And we'll definitely share images of the final results from the workshop and things like that.
Yeah, I would love to see. And enjoy. And when is it gonna, is it within the next few days? How many days do you think it would take? Exciting. I hope it all goes as planned, and even better.
Thank you.
Thank you.
Bye-bye. Lovely to meet you.